So these are the bases of the tetrahedron. The tetrahedron, I just make it. Some tetrahedron is there in front of you. Their planes equations are given. Okay. And then the volume of the tetrahedron. Tetrahedron volume, you know that if you know A, B, C and D. Tetrahedron volume is 1 by 6 of STP of their adjacent sides. Let us suppose I say DB, DC and DA. Okay, that is the volume of tetrahedron. So my concern is that I should get this vertices. Without that, the thing cannot be possible. It becomes pretty difficult to analyze instead of this by plane. Volume cannot be found out with respect to plane. We need to find these vertices. Means intersection of the planes. Here three planes are cutting each other. One is ABC plane, one is ADC plane, one is ADB plane to form A. So what I'll do, I'll open it in Cartesian form. I'll write the answer as Lx plus My equals 0 is plane number 1. Plane number 2, Nz plus My equals 0. Plane number 3, Nz plus Lx equals 0. Plane number 4, Lx plus My plus Nz equal to P. Now you need to take 3 at a time and solve. P1, P2, P3, one vertex will be obtained. P2, P3, P4, another vertex will be obtained. P3, P4, P1, another vertex will be obtained. And P1, P3, P4, another vertex will obtain. All the 4 vertices you should get. That 4 vertices when you get, you apply this rule and you get the answer. And hopefully the answer is, I think, is your D. When you solve. I told you the procedure. If you have not understood, do let me know. You understood what I did? Can you go ahead? A be any event in the sample space, then the maximum value of this. Again, maximum comes, so either apply AMGM or you go with calculus. It would be better you go calculus. PA, assume as T, some value, 3 times T plus 4 times under root 1 minus T. Take it as some L value. Do DL over DT and get the answer. Can you do that? Shall I tell the answer or you are clear with this? Answer is, I think, C. Not this one. This one. The answer is C. Now let's go to this one. And this is a good question. I just want you to just understand or visualize the thing which is being given. There are 2 things which I just want to teach in this question to you. One thing is that you know very well this written BC minus n square is forming from this place as a determinant. Can you see this? Observe this. Understand. Mn minus Lc. Mn minus Lc is this. What I want to say, this is nothing but a cofactor matrix of this, a cofactor matrix determinant of this matrix, if it is considered. Understood what I said? If I take A matrix as this one, ALM, LBN, MNC, okay? then this will be my cofactor matrix of A. BC minus N square, MN minus LC, LN minus BM, MN minus LC, AC minus M square, LM minus AN, AB minus L square. Clear? So, this is a cofactor matrix, and cofactor matrix transpose is your adjoint. You know that? And when I talk about the determinant of it, please understand. So, determinant of transpose or determinant of cofactor matrix is nothing but determinant of adjoint. So, determinant of adjoint A is nothing but equals to determinant A power n minus 1. Clear? So, this is determinant A. This is nothing but determinant A square. We got determinant A cube as 64. Determinant A becomes 4. I want to know this. Now, how to check this? Understand carefully. ALM, LBN, MNC, they are being used only with their scalars being some multiplication. So, how to analyze this? You just pick 2, 3 and 5. 2 into 3 into 5 will come in one scalar 1 plus 3, 5 and 4. This comes another one multiplied by determinant A. This is easiest way to remember. This is the splitting of subdeterminant. If you do, this will become very lengthy. Just remember with this scalar system. You get 2, 3, 5, 3, 5, 4, determinant A. Determinant A is 4 and this value is 30. This value is 60. 60 plus 30, 90 times 4 is 360. This answer is also 360. What I did, understood? First elements A, LN, LBN and MNC. 2, 3, 5 is running. Take 2, 3, 5 and then you take 3, 5, 4. Have you understood? Shall we go to the next? Now, a bag contains M white and 3 black balls. Balls are drawn one by one without replacement till black balls are drawn. The probability that this procedure drawing of balls will come to an end at the rth draw is equal to. I think that you understand. M white, 3 black. So we need to draw without replacement till a standard question. Rth draw, you get a black ball and remaining 2 balls you should get it before it. 2 black balls and remaining white balls should also be drawn. So I have to do R minus 1 draws before it. Out of that R minus 1 draws, I should get 2 black balls and remaining R minus 3 M balls in that draws. That could be any draws. So I will do out of this 3, 2 balls first of all you should draw. And balance M balls you draw. R minus 3 draws you draw from that M balls. And then you have M plus 3, CR minus 1, because Rth you have to get this draw only. 1C1. This is black ball. Isn't it? This is the story. I think this matches with your C part. You understand what I'm telling? It is actually a complicated one when it comes in M and R type. If they say very simple, na? That you have 10 white balls, let us suppose, 3 black balls, let us suppose, and they say that one by one ball is drawn in the seventh draw. In the seventh draw, last black ball to be taken out. Seventh draw. What happens? Before seventh draw, you have 6 draws. In that 6 draws, only 2 black balls are coming out, and balance 4 balls to be coming out is your white one. So you do one thing, that last draw is 7th draw, you are getting a black ball, so you'll write 1C1, that we are taking out the black ball only out of that. So before that, what is happening, that you have to see. This is a one choice only, you don't have any other choice. Only one black ball is pending, you go with this. So in this case, what you do, you are doing 6 draws. In that 6 draws, what happened? 2 draws consumed for getting black balls, and 4 draws you will be drawing white balls. That 6 draws happened for this getting out of this 13 any 6 draws, any 6 balls. Am I clear? So in numbering you get the answer very fast, but if it is written in M and R and N, it takes little bit equation to be framed and solved. Okay, am I clear? So going to the 5th one now. The position vector of points P and Q are given. So P is given as 5, 7, minus 2. Q is given as minus 3, 3 and 6. The vector A, 3i minus j plus k, passes through the point P. Okay, this is passing through this. And vector B means that drs are given. Minus 3i plus 2j plus 4k passes through Q. So you get a line from this as x minus 5 over 3, y minus 7 over minus 1 and z plus 2 over 1. And you get the line from this x plus 3 over minus 3, y minus 3 over 2 and z minus 4 over 6. These are the 2 lines with point direction form, you made it. Third vector is there, means these 2 lines are there. Third vector means having drs as 2, 7 and minus 5. They are the drs of the third vector. Intersect A and B, means intersect these lines with these drs. The position vectors of the point of intersection, means if this point is L and this point is M, so I want to know this L and M position vector. So it is not difficult, only the thing is you got these lines. This is line 1, let us suppose, made from this. This is line 2, made it from this. So you take a journal point by taking lambda 1 on this and lambda 2 on this. So you got in this point assumed as 3 lambda 1 plus 5 minus lambda 1 plus 7 and lambda 1 minus 2. You understanding what I am doing? And this M I am going to get from this place, minus 3 lambda 2 minus 3, 2 lambda 2 plus 3 and 6 lambda 2 plus 4. I got this from line 2, from line 1. Its dr is given as this. What I do? A2 minus A1. Dr I will form and proportional with this. I will get 3 lambda 1 plus 5 minus this. Over 2 equals. I'll make second one minus lambda 1. I'm removing this because we have used it. Minus lambda 1 plus 7 minus 2 lambda 2 minus 3 over 7 equals the last one. Lambda 1 minus 2 minus 6 lambda 2 minus 4 over minus 5. You equate 2 at a time. Take 2 at a time. This one first. Get equation in lambda 1, lambda 2. Take this one with any one, either this or this. Take another equation, lambda 1, lambda 2. Solve it, you get lambda 1 and lambda 2. Hence, position vector will be obtained. Clear? So, next one. This is the probability of A to win a game and against B is 0.4. A has an option of playing either best of 3 games or best of 5 games. X is probability of winning A against B by choosing best of 3 games. So best of 3 games means 2 won, 1 lost, or all the 3 won. For A to win. Okay, and PY is best of 5 games. You have 3-2, 1 game, 4-1 another game, or 5-0 another game. Right? They want PX and PY combination. It is nothing but just a calculation game. Winning of A is 0.4. Winning of A is 0.4, so 0.6 is winning of B. You write the answer. 2 games won out of 3, so 3C2, 0.4 square and 0.6 power 1 plus 3C3, 0.4 cube is the answer of PX. Then you go with 5C3, 0.4 cube and 0.6 square. 5C4, so this value you should obtain, this value you should obtain, then you just compare the answers. Am I clear? Seventh question. A is a non-singular matrix of order n cross n. N cross n order is there. 3 times A, B, A inverse plus A. To A inverse BA. Then A and B are identity matrix. Mod of A plus B, determinant of A plus B is 0. A plus B is non-singular, that you have to check. A is a non-singular matrix, not told about B. So what to do? That case, multiply with 6. Have you done this question? 7th. B and C are the options given. How to do this? In this procedure is pre-multiplying, post-multiplying, everything will be done. Do one thing, something common to be taken, make it 2A addition here and 2A addition here, so that we can take something 3 or something common. You understand? 3A B A inverse plus 3A equals 2A inverse BA plus 2A. You understand what I did? 3 should be taken common, A should be taken common. Like that, I made it this something. So what I'll do, you can take 3A common from this place. You have B A inverse plus I. Clear? And this place you take what can you take common? Nothing. Will it be possible to take anything common from this place? If I take A inverse common, okay. Let's begin with A inverse common. Should have A square there, na? A inverse. Okay, we'll see this question. Let's get back to the next. This one. This I think you can do. 8th one. Yeah, dear, tell me. 8th one. Can we check this? OA square plus BC square equal to OB square plus CA square, OC square plus AB square. OABC is a tetrahedron such that OA square, which thing you will match? I will take it OA as some CBA. Let us suppose A is taken here. So OA is AI. OB is BJ. OC is CK. OA square is what? A square. BC square is what? C minus मतलब CK minus BJ square. Right? Means C square plus B square will get it. And is equal to OB square is nothing but B square. That will also come A square plus B square plus C square. Means what? You are getting, that means they are perpendicular. If we take a bigger one, then it will not be perpendicular. It means they are perpendicular. This is the answer of 8th. Answer is given A, B and C. Means OA is perpendicular to BC. No, that is not supporting. In this case, it is not supporting. I don't think so. The answer is correct. Or we are doing something else. If we take some random vector, then what will happen? Okay, just take random vector, then check what is happening. OA position vector A, OB position vector B, OC position vector C. Let us suppose this. Okay. Then BC is what? C minus B vector, right? So OA square is nothing but A vector square. BC is nothing but C minus B vector square. Should be equal to B square plus A minus C square. Now open it up. You get a square, you get c square, you get b square minus 2b dot c, b square plus a square plus c square minus 2a dot c. A square, c square, b square, a square, c square, b square cancelled. This is cancelled. B dot c equal to a dot c. Take it here. B minus a dot c is equal to 0. B minus c is ab dot c is OC. So AB perpendicular to OC, coming one answer. Similarly, when you do with this with third one, you get the second answer. This with first one, you get the first answer. Understood?